Let's take a look at how we can index into memory. So here's a program that's supposed to go through an array of words and add up all the values. So go ahead and complete the loop so it does this. So we're missing some stuff in the loop here. And then look at how you could simplify the loop if you had an auto increment load instruction. So that's instruction here, load word, register, register, and then it has plus an offset. So that can increment the value after the load. So it'll increment R4 after it loads. And then finally, if you had this, how much faster would it be? How would it change the number of instructions that are executed? So let's take a look at completing the loop. So the first thing we need to do in the loop is we need to load the value. So if you look at the code that goes on here, T0 has the start address of the array, T1 has the size, and T2 has the end. And so T3 is going to be where we store the sum. So T0 has the start of the array, we're going to load it into T4, okay, and then what do we want to do? Now we're going to add that value into the values we have so far. So T3 is storing all the values we have so far, our sum. We're going to load T0 into T4 and add it to T3. So now we've summed it up. And then finally, now we need to go on to the next word. So we're going to increment T0 by 4. And then we check to see if T0 is at the end. If it is, we're done. Otherwise, we continue around the loop. So this is the code to make the loop work. Now, what could we do if we had this fancy instruction? Well, if we have this fancy instruction, we can go in there and we can go ahead and load the data from T0 into T4 and increment T0 at the same time. So I've got one instruction that does both of those. We need to do the same part where we sum up the values, adding T4 into T3, but now we don't have to have a separate instruction to increment T0. So what does this do to performance? Well, before that we had 4 instructions in our loop. We had the load word, we had an add, and a branch not equal, and we had to do the loop 16 times. So we'd have 64 instructions in there. Now we only have 3, and with only 3 of them we're only doing 48 instructions. So it's 25% faster if we had that instruction. Let's take another look at practicing loop branching. So here we've got code that's going to go through 64 bytes of memory at address 128 and decrement each word value. So there are 2 things we want to do. The first is add the missing jump to make it go through the whole array, and then go ahead and add a branch that exits the loop early if the value is 0. All right, to understand what's going on here, let's take a look at the code. So the code starts out by doing some setup. Puts into T0 the start of the array is at address 128, and then it puts the last address of the array into T1. So it's going to add 64 to T0. Now we go through the loop. So in the loop, we're going to load the value at T0 into T3 as a temporary. We're going to decrement it, and then we're going to store it back. Then we're going to go on here, and we're going to go to the next one. We're going to take our address and add 4. And finally, we're going to check if our address is at the end, and if it is, we go to exit. Now, what happens if we're at exit? We're here, but we're not at the end. So if branch equals not true, we're going to go ahead and exit anyways. So this is where we need to put in a loop that'll bring us back. All right, so here we go. We need to put in a missing jump. That's down here. If we're ready to exit, we should branch equal to exit. Otherwise, we should jump back into the loop. Now, if we want to add a branch that exits the loop early, if we read 0, well, we should just go here after we've loaded something, and we should check. Branch equal, if the value we loaded is 0, go on to exit. Now we have code which will exit early if we load a 0, and is going to go back around and around until we reach the end of our array.